Hello, this is your Lakshma Reddy sir, class 10 chemistry, chapter 2 acids, bases, and salt. You have learnt in your previous classes that the sour and bitter tastes of food are due to the acids and bases respectively present in them. Respectively means sour due to acids, bitter due to bases. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, and baking soda, or baking soda, right? So, already acidity is there because of overeating. When acidity is there, that means when our body has more acids, we need to give bases, right? And you are going to suppose baking soda solution. The suggestion from you will be baking soda solution, or you can say simply. Okay, now, and lemon juice formula is like this: three carbons, first, second, third. All the three carbons contain COH group, and second carbon contains extra OH. Okay, that's lemon juice. Vinegar is acetic acid, that is well known to you. Baking soda is an HCO3. Just for your idea. Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Correct? Acid plus base gives rise to salt and water. This reaction is called neutralization. Acid plus base gives rise to salt plus water. Right? So overeating causes acidity. So you need to give some amount of very dilute and very less effective base. Don't give very strong base because acid and base reactions are highly exothermic. Okay, now if a strong acid and strong base is added, you'll be getting salt, water plus lot of heat also will come. Okay, then it will be burning sensation too, right? So don't use simple techniques at home. Visit doctor if any emergency is there, right? Don't apply lab chemistry on bodies. Chalo, recall how we tested sour and bitter substances without tasting them. We should not taste because we don't know whether it is poisonous or not. So we should not taste without tasting. That means you need to use indicators. Okay, now without tasting, we need to use indicators. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Blue to red is acid, red to blue is base. This is well known to you from class 6 or class 7. Litmus is a natural indicator. Turmeric is another such indicator. Turmeric. Okay. And have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? Okay, it turns yellow again when the cloth is washed with plenty of water. Okay, now when you are removing that base, okay, now see, have you noticed a stain of curry on a white cloth becomes reddish brown when treated with a soap? Soap is basic in nature. That means when you are adding base to the curry, it is turning into reddish brown color. And when the base is removed, again it is coming back to the yellow color. Okay, just for observation. That means it is also kind of indicator. Okay, now because our curry contains, yes, turmeric. Okay, now we generally Indians use turmeric in curries. I don't know about Americans. Fine. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Okay, methyl orange and phenolphthalein. If you see phenolphthalein in acids, no color, bases pink color. Methyl orange in bases, yellow color, acids, red color. Okay, we will discuss that again. In this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effects, and many more interesting things that we use and see in our day to day life. Do you know? Litmus solution is a purple dye which is extracted from lichen, a plant belonging to the division Thallophyta, and is commonly used as an indicator when the litmus solution is neither acidic nor basic, its color is purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, geranium, which indicate the presence of acid or base in a solution. These are called acid base indicators, or sometimes simply indicators. So no need to remember all this because this is the extra part. No need to think what will be the color of hydrogen. No need. Okay, simply remember. Okay, along with litmus paper, you can go with turmeric. You can go with some cabbage leaves and some flower petals. Yes, question. You have been provided with three test tubes. One of them contains distilled water and the other two contain an acidic solution and a basic solution respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? Red litmus paper, blue litmus paper, blue to red is acid, right? Red to blue is base. Red is given. If the red turns into blue color, then that is base. This is the only one that you can do. If you are taking water, water is neutral, so the color won't change. And if you are taking acid, also no change. So you can change only base. Okay, you can check only base. Remaining two you cannot. Coming to 2.1, we'll cover this 2.1 also in this section. Then in another video, we'll go with 2.1.2 like that. Okay. Let us see what are given in this 2.1, understanding the chemical properties of acids and bases. Acids and bases in the laboratory. Collect the following solutions from the science laboratory: HCl, H2SO4, HNO3, acetic acid, NaOH, KOH, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. First to four are acids, next to five are bases. Put a drop of each of the above solutions on a watch glass one by one and test with a drop of the indicators. So tell me how many test tubes, how many watch glasses we need? 9 are there. Okay, now. And we are going to use phenolphthalein, methyl orange, red litmus, and blue litmus. So you need to use, okay, 9 watch glasses minimum, one by one we'll see. Otherwise, 36 watch glasses you take. Okay, go for 4 different tests. Tabulate your observations in table 2.1. See, sample solution, red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. Okay, we'll do one thing. We'll take up here, right? Sample, red litmus, blue litmus, phenolphthalein. The spelling is very interesting. Methyl orange. Okay, so there are HCl, H2SO4, HNO3, and acetic acid. 4 acids are given. Then 5 bases are given: NaOH, KOH, calcium hydroxide, CaOH taken twice, magnesium hydroxide, MgOH taken twice, and ammonium hydroxide, NH4OH. Fine. Let's take one by one these. Blue to red, blue litmus to red litmus is the characteristic of acids. So red litmus, for all these 4 there is no action. Blue litmus will be turning into red, 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 and red because these are acids. Correct? And these 5 are bases. So bases have no effect of blue litmus. Bases turn red litmus paper to blue. Okay, na? So this will be converted to blue, 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 and blue. One more blue. So this you are doing actually practically. I'm saying with my practical knowledge, right? HCl, H2SO4, HNO3, CS3COH are acidic, so they turn blue litmus to red. And NaOH, KOH, calcium hydroxide, magnesium hydroxide, ammonium hydroxide are bases, so they turn red litmus to blue. Then phenolphthalein, as we were discussing, phenolphthalein, okay, now when you are taking acids, no color. Okay, there is no color for phenolphthalein, so colorless, 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 colorless. What about bases? Pink, 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 all pink. Okay, na? Methyl orange. In methyl orange, bases will be having yellow color, yellow, 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 and these will be having red color. Okay, now we have tabulated HCl, H2SO4, HNO3, and acetic acid, NaOH, KOH, calcium hydroxide, magnesium hydroxide, and HOH. If possible, ask your teacher to show at least one or two. Maybe your lab contains some litmus papers, and otherwise, you can at least see YouTube videos. Better to do practically in the lab. Phenolphthalein, methyl orange are definitely available in your lab. Litmus papers depends on your school. Fine. Chalo, come back where we are. This is the one. Okay, so here for sample purpose we'll write two things. One is HCl, second is NaOH. Red litmus. Okay, now HCl is acid. Okay, now acids. Blue litmus to red is acids characteristics. So this is no, this is blue, this is no. Phenolphthalein indicator. Phenolphthalein indicator basic solutions have pink color and acids no color. Methyl orange bases will be having yellow color and this will be having light red. These indicators tell us whether a substance is acidic or basic by change in color. There are some other substances whose order changes in acidic or basic medium. These are called olfactory indicators. Olfactory indicators. Let us try out some of these indicators. Take some finely chopped onions in a plastic bag along with some strips of clean cloth. Tie up that bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their order. Keep them on a clean surface and put a few drops of dilute HCl. Dilute HCl solution and one strip and a few drops of dilute NaOH solution on the other. Okay ना. So simple. आप ऑनियन कट कर रहे हो ఓకే నా మీరు ఆనియన్ ముక్కలు ముక్కలు చేసేసిన తర్వాత ఆనియన్స్కి స్మెల్ ఉంటుంది బేట మనం చేస్తుంది ఏంటంటే ఇక్కడ వాట్ వీఆర్ యాక్చువల్లీ డూయింగ్ ఇయర్ ఈస్ हम क्या कर रहे हैं यहाँ पे इस ओके ना आई बिलोंग टू तेलुगु प्लेस सो आई स्पीक इन तेलुगु बिट हिंदी बिट इंग्लिश राइट सो जब आनियन पीसेस हो जाता है आनियन का एक पर्टिकुलर स्मेल रहता है जब आप आनियन खा के बाहर जाते हो तो दूसरों को पता चल जाता है कि आप आनियन खा लिए सो आनियन का स्मेल इतना स्ट्रांग रहता है बेटा एंड ऐसे आनियन को आप एक दिन के लिए एक रात के लिए पूरा फ्रिज में डाल दिए और उसके साथ में कुछ క్లాత్స్ लगा दिए మన కొన్ని క్లాత్ ముక్కలు పెట్టేసి చిన్న చిన్న బట్ట ముక్కలు పెట్టేసి ఆనియన్స్ అలా పెట్టేసినందుకు ఆ బట్ట ముక్కలు కన్నిటికి ఆనియన్ ఏమంటుంది స్మెల్ పట్టేసుకుంటుంది ఓకేనా ఆనియన్స్ స్మెల్ విల్ బి విత్ ద cloth pieces. Now, that cloth pieces we are using with dilute HCl and dilute NaOH solutions. అలా చేసేసిన తర్వాత వాటిని యాడ్ చేసిన తర్వాత rinse both cloth strips with water and again check their order. Note your observations. Now take some dilute vanilla essence and clove oil and check their order. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. Add a few drops of dilute vanilla essence to the both test tubes and shake well. Check the order once again and record changes in order, if any. Similarly, test the change in the order of clove oil with dilute HCl and dilute NaOH solutions and record your observations. The observations are very simple. Okay, na? When you cut onion pieces or when you take the dilute vanilla or when you take clove oil, all these have some specific and that smell remain constant in acid smell no change. Simply you remember this. And in bases all they lose smell. All these what are we are saying, this vanilla, this clove oil, where the clove oil gone, clove oil, vanilla and onions, all these lose their smell in basic medium, not in acid medium. Which of these, vanilla, onion, and clove, can be used as olfactory indicators on the basis of your observations? All the three. Vanilla we can use, onion we can use, clove we can use. All they have some smell, and the smell remains same in acid medium, not in basic medium. All these can be used. Let us do some more activities to understand the chemical properties of acids and bases. This we'll do in next class. Thank you.